Currently, we use direct transmission cables to communicate. When billions of photons are sent through wires, the light pulse is on 1, otherwise on 0. The problem that arises due to this method is photon loss over long distances, which limits its application to distances less than 100 kilometers only. Photon loss can be reduced by using quantum physics and quantum repeaters. First, let's understand its basic principle, quantum entanglement. Imagine that these are your earphones. You place them in your bag. While reaching for them, the one that you pick first is in an undecided state or superposition. But once you take it out and see that it is the left pair, you know instantaneously that the other one is the right earphone. Now imagine each earphone as a photon and left and right as opposite polarizations. Knowing the state of one photon instantaneously tells you the state of its pair, regardless of the distance between them. Quantum repeaters use this principle to relay information from A to B. The path is broken down into smaller distances demarcated by intermediate nodes. Photons exist in entangled pairs, which you can imagine this way. Two photons, one from each consecutive pair, swap or are sacrificed. This leaves a longer chain entangling two distant photons. This happens at each intermediate node to transmit data through a daisy chain. However, this setup requires photon synchronization. All swaps must happen at the same time, and if not, the chain of swaps would be repeated. To avoid this circumstance, memory stations are used. They store the non-switching photon until the swap is successful, then release the stored photon for the next swapping step. This needs only one repeated swap rather than 3 in case of an asynchronous transmission. Now the question arises, can we integrate quantum repeaters into existing communication cables? In 2023, Ben Lanyon and his team at the University of Innsbruck succeeded in building a quantum repeater node for the standard wavelength of telecommunication networks, transmitting information over 50 kilometers. Improvements can increase this range to 800 kilometers. This proves that quantum repeaters are the next big thing for telecommunication.